Hey, good day, everyone. What we're going to be talking about today is going to be basically the starting lesson of actually simplifying trig using identities. Okay. Um, Understand one of the key things that we're going to be doing in this lesson is using those reciprocals as well as those Pythagorean identities to help simplify trig functions. This is why we talked about it yesterday. It's why we spent a lesson just going over what those values were. Okay. In today's lesson, you're actually going to see the application of those identities. Okay. Now, understand, I kind of talked about this yesterday, and I'm going to kind of rephrase it today. All right. These problems at some points are kind of like a puzzle. Okay. You are looking for instances that you can use an identity to help simplify a problem. Springboard, the actual Springboard book itself actually does a decent job with giving you some strategies sitting right here. Things like substitute using an identity, use multiplication or factoring if you can. Okay, rewrite the terms and expression of sine and cosine. Once again, kind of giving you some different strategies that you can use. All right, and while these key strategies are very helpful, one of the key things I want you to understand is you can't necessarily get frustrated with a problem that deals with an identity. You have to take the time and really just try to think through what can you do next. Okay. On top of that, like we talked about on the getting ready day, this lesson is going to kind of start to test your algebra. Okay, especially things like adding and subtracting fractions. How comfortable are you with factoring? Um, how comfortable are you with dividing fractions and things like that? Okay, so work with these examples, kind of work through them, and then, as always, when you have a question, ask, and then you can start to see kind of the process to get to a final answer. Okay. But before we even get started, let's actually look at an example, one that's done for us. Okay. If you look at example A right here, one of the key things you have to understand is how they're actually building up to this problem. So notice how they give you an equation sine, cotangent, and secant. Well, the idea of this is I need to be able to simplify that as much as I can. But to do this, I need to get things that are common. I need like terms. And a lot of these problems that we have can be turned into sine and cosine. So notice what they do right here. They rewrite everything in terms of sine and cosine, and that way they can start canceling things out, which eventually leads to that third part, the simplify part, and everything cancels, and you're left with an answer of 1. So crazy enough, this long trig function just equals 1. Okay? So notice how they did that. They took what they had in the equation originally and used those identities to help rewrite the problem and simplify it. Same can even be said down here. Okay. This one in example B is a pretty tricky problem because when you look at it, you don't really see a possible way to get to your next step. But notice what they do. They notice they have a tangent squared and a positive 1, and they say that's one of our Pythagorean identities. So they can say if that is a Pythagorean identity, you can substitute in secant squared, which secant squared minus secant squared would just give you an answer of 0. So notice how it's almost like a puzzle. Like you're trying to find the identity in it, okay? I just do past years call almost like a Where's Waldo problem. Okay, I don't know if anybody reads those books, but that's kind of what it's like. You're trying to find where you can use an identity to help solve a problem out. Okay. So let's kind of develop this and let's kind of build off of this within the try these A and B. Within try these A and B, we're going to start looking at like how can we actually simplify this? Well, once again, I want to try to think about where can I actually simplify a problem out? Well, here's kind of the first thing I see. If I look at letter A here, I'm trying to think about what can I use? Well, I start seeing the squares off the bat, right? Notice how this is cosine squared and sine squared. Automatically, the second I see that, my head should be going to Pythagorean identities because out of all the identities that we have so far, those are the only ones that had squared values in it. So now I want to try to see, can I find any of my Pythagorean identities in this problem? Well, if you notice, cosine squared and sine squared actually are in themselves a Pythagorean identity. They just equal 1. So I can substitute in and say, okay, cosine squared plus sine squared equals 1. So I'm going to substitute this in and say it's just 1 minus 1, or you get a final answer of 0. Okay? Notice how I kind of work through that example. If I go to letter B, okay, And I'll do letter C at the bottom there just to kind of give myself some more room. Okay? Actually, I won't erase that. I'll write it down there. Let's just extend the page and write these out. If I look at letter B here, we have cosine of theta, cosecant of theta, all over cotangent of theta. Well, once again, I want to look at this problem and start thinking off the bat, what can I do? Well, I don't see a squared in there. So automatically, I can cancel out my Pythagorean identities, at least for now. Like, I can't really use them. So what's the point of really worrying about them? Okay? So now I want to look at this and say, okay, what can I do? Well, I can rewrite all these values in terms of sine and cosine because they all have an identity that represents that. For example, cosine can just stay cosine of theta. Cosecant is just 1 over sine of theta. Okay, that's the top of the fraction. On the bottom of the fraction, we have cotangent, which is just cosine of theta over sine of theta. Well, notice how I can simplify these values. I can rewrite the cosine and sine on top to get cosine of theta over sine of theta on the top of the fraction, all over cosine of theta, all over sine of theta. Now, I could do skip, flip, multiply here, but we actually don't need to, because now I can take my rules of things we've talked about before. If the thing on top is the same value as the value on bottom that we're dividing by, then these should naturally cancel out and give you an answer of 1. Okay? So notice how I did that process. I turned everything into sine and cosine and started simplifying those values out until I got to a point where I can look at that and say, okay, these two cancel, leaving me with this singular value. Okay? Let's go ahead and look at one more. Let's look at letter C. Letter C is going to be secant of theta 1 minus sine squared. So we have secant of theta, and then we have 1 minus sine squared of theta. Okay? And for this one, I'm going to show you a little trick here. So I'm going to draw a little squiggly line on it so we can talk about a couple of things. So here's the deal. Here's the first thing I notice. Okay? First off, we talked about our rules. I want to get things that can match up. I also want to try to be smart when I start this problem. I see 1 minus sine squared of theta, and I'm thinking, okay, I have a sine squared, which means I'm probably using a Pythagorean identity. But the only Pythagorean identity that has sine in it is cosine squared plus sine squared equals 1. Okay? Well, here's the thing. What if I were to rearrange this identity? What if I were to subtract sine to the other side? Wouldn't this just be cosine squared of theta equals 1 minus sine squared of theta if I just subtract that whole value over? Well, now look what I have here. This matches this. So not only can I just use my identities, I can actually move them around to get to things that can match up with with what I have in this original equation or in this original problem. So now I can substitute in this for this function. On top of that, secant is the same as 1 over cosine. So I can really write this as 1 over cosine of theta times cosine squared of theta. Well, I have 2 cosines on top, 1 cosine on bottom. This would cancel out and take out one of those cosines, and my final answer is cosine of theta. So notice how I can actually build off of this problem and actually get to that final solution, okay? Let's keep going on this. Let's kind of continue on and go from here, okay? So that's going to be a lot of what we really focus on in this lesson. We're going to really try to build off of this type of problems, okay? We really want to try to be able to use our identities to our advantage to help get a final answer or a final solution, okay? So let's kind of build. Let's kind of just get a little bit more complex and start really trying to understand, like, how can I actually use this to our advantage, okay? So let's talk about this one here. Letter A here, we have cosine of theta and then we have 1 over sine plus cosecant. Once again, we want to try to understand how can I actually simplify this? Okay, well, let's go ahead and try to work this out. Well, how I look at this is, let's work about what's on the inside. This is really cosine of theta multiplied by 1 over sine of theta plus 1 over cosecant is also sine of theta. This is where we start testing our algebra skills. Notice how we have the same common denominator, which means this would become cosine of theta equals, or excuse me, not equals, parenthesis. When I add those fractions together, that would become 2 over sine of theta. And then when I multiply cosine in there, it becomes 2 cosine of theta over sine of theta. Now, the last step to simplify this is technically, if I don't even worry about the 2, cosine and sine is its own identity, right? Cosine over sine is the same as cotangent. So really, this could be simplified to be 2 cotangent of theta. So once again, notice how I'm just turning things into terms of sine and cosine, combining them all together to get to a point where I have a cotangent, okay? The rest of those are going to be pretty similar, and we can worry about those in class. But once again, this kind of concludes that first portion. What we'll really focus on the day 1 of this, okay? Day 2, the second ed puzzle I'm going to have you watch, is going to focus on verifying. And this is going to be basically they tell you what the final answer is, but you have to prove it using your identities, okay? And we'll finish this off with the second ed puzzle just to kind of keep your time stable. Besides that, answer any questions, and we'll be in class tomorrow discussing this, okay? Have a great day, and I will see you tomorrow.